Hey guys, Professor Doney back here. We're slowly moving towards two-dimensional motion. In the last bunch of videos we did, throw up, throw down, dropping, go up, come back down, and also horizontal stuff. Now we're going to look at two-dimensional motion. And two-dimensional motion means we're going to be moving horizontally in the x direction at the same time we're moving up, which we'll call the y direction. Now when we do those both at the same time, so I'm doing this and I'm doing that at the same time, what happens is the object typically will have this kind of shape if we just throw it up and drive across. So if you're driving in your car and play catch to yourself, you see the ball just go up because you're sitting in the car, but someone going by you would see the ball go up and then come back down. They'd see it go over a longer distance. And we call this two-dimensional motion, also projectile motion. Projectile meaning the object is projected and lands somewhere else from where it started. So it actually gets displaced horizontally, but also it moves vertically in the y. Now to look at two-dimensional motion, we have to get into a little bit of trig and deal with angles. So we're going to do that real quick here. So let's say I have a right triangle. Well, close to a right triangle there. I'm going to call one side A, call the other side B, and this really long side C, which is the opposite of the 90-degree angle. Now I'm going to label this angle as alpha, a little circle with a line across that, or theta, I'm sorry, I'm going to call it theta, which is typical for math folks. Now you may have seen it with the ABCs. We could also write it as, if I redraw this real quick, there's theta, there's 90 degree. We sometimes call this the adjacent side, we sometimes call this the opposite side, and we refer to this as the hypotenuse. I'll abbreviate it by HYP, hypotenuse. Hypotenuse is always the side opposite the 90 degree. It's always the longest side of the right triangle or 90 degree triangle. Now a couple ways to deal with this. If I know two of the sides, if I know the adjacent side and I square it and I add it to the opposite side squared, I will get the hypotenuse side squared. This is known as Pythagorean's theorem. Pythagorean's theorem allows me to find the third side if I knew two of them. So if I know these two, or I know these two, or I know the adjacent hypotenuse, Pythagorean theorem helps me find that. Okay? Now the other way we can deal with this, if we know the angle, we can use trig functions. Now trig functions are things like cosine, which many times you'll see it as COS on your calculator. And if we take the cosine of the angle, cosine of theta, it will equal the ratio of the adjacent side divided by the hypotenuse. If I take the sine of an angle, or on your calculator SIN, it's the side opposite divided by the hypotenuse. Cosine is the close side or adjacent side. And the last one that we sometimes use is tangent, or TAN on your calculator of an angle. That's always the opposite over the adjacent side. So if I take the adjacent side up here divided by hypotenuse, whatever these numbers are, and take cosine of the angle, equal that. Now typically what we do is going to not put them in those forms. Let's grab a different color here. I forget which colors people said were working well, but we'll just get a little gold here. Is we're going to take those, and if I take the inverse cosine, the angle equal the inverse cosine. Now it says cosine -1, the arc cosine some people say, and that would still be the adjacent over the hypotenuse, and so on. So that gets us started with the trigonometry. I'm going to do a second video here in just a second to add on to this, to go a little deeper with this, because this isn't enough for us to go two-dimensional. So just hang on, check out the next one. I'll finish up all this cosine, inverse, arc sine stuff, and we'll go from there. Thanks, and we'll see you next video.